Okay, I think we can start. Okay, this is John from DapuStor. We're very happy to make this happen in this great show. So today I think PCIe 5 is kind of hot, and because the performance has double compared with PCIe 4. So we DapuStor have faced some challenges, and we have overcome this kind of challenges. So in this presentation, we'd like to summarize what we have done to overcome these challenges. So I hope it will help for your reference. Let me give you a brief introduction about DapuStor. DapuStor is a high-end enterprise and data center SSD solution provider. We have several product series, including Excellent Store, we called SCM SSD, or very low latency SSD, which is alternative of Optane SSD. And we have Roison and Haishan series, which are targeting the TLC and QLC SSD. Today we are focusing on the Haishan 5, which is PCIe 5 SSD based on Marvell latest Bravia controller. So yeah, let's go to the challenge what we have faced. So the first challenge at the module or solution provider, the supply and cost every time this goes first. So we need to select the latest controller NAND technology. So as you can see that we are enabling Marvell Bravia technology. It's the latest, I think it's fattest controller in the industry, and we are enabling Kioxia Big 6 and Big 8. You can see that our Big 6 products small mass production, and we will have another version in 2024 based on Big 8. So based on this kind of combination, we can guarantee or provide our customers with better supply flexibility or cost advantage, etc. Yes, next is the signal integrity. You know that PCIe 5's kind of signal rate is quite high. It's up to 32 gigahertz transfer per second NRZ. So we know that there are many requirements regarding the signal integrity. So we have the JEDEC standards, such as we need to have the low insertion loss during the end-to-end pass. So we have compared many combinations between the PCB materials and the thickness of the stack and the layers PCB design. So finally, we got a design with very best PCB material and the return loss. So to achieve the signal integrity. Another one is the high performance. As you know that PCIe 5 performance quite high, but there's a performance limitation. The power limitation. So what we have done is we have fine-tuned the firmware very much. So of course there will be firmware. The easiest way is to slip the firmware job to server core groups. But what the side effect is, the CPU utilization was not so high, so that means the performance is not so high. So what we have done is carefully evaluate the function of the firmware and divide the core with the the firmware. It's like what a core to do read, what a core is to do write. So this brings out the very best CPU utilization, and we have expand over NAND over provision. So after this kind of optimization, we have done some demonstration testing, which you can see that our performance have increased much better. It's like 16 to 34% higher compared to another models. Also 200% improved with other model. And on the other hand, our latency and queue is much better than competitors, even in the different namespaces. So the outcome is quite impressive, as you can see that we have several form factors, including the UDA2 and EDSFF, E1S as well, E3.S, and the performance, you can see that random read up to 2.8 milli IOPS, and the random write goes to 560K for write-intensive drive, and 250K IOPS for read-intensive drive. And the most impressive thing is about the latency. You can see that the random read latency is lower to 55 microsecond, and 7.5 microsecond for random write latency. We also have a partner, which is a RAID solution provider. Yes, great. So we have solution testing with great, and the bandwidth and the IOPS have been improved very much compared to PCIe 4 drives. You can see that our bandwidth have increased like 125%, and the IOPS have increased to 115% compared to current PCIe 4 drives. So I think it's should be much better for current AI applications, and will benefit for the customers. Yes, this next one is about the summer. If the usually the performance is higher, the power is higher. So we need to carefully design the including the material, the mechanical, the L duct, and the component, even the component layout, and the circuit design as well. So after our careful design, we can see that the result is quite good. Our simulation regarding the summer has a very great outcome, and is fulfill all the components requirements. Yes, next a challenge is about the features. I just summarized one of the feature, which is SRV, because now customers requiring larger and larger density. So for CSP is usually targeting for the consistency service for the cloud user. So SRV should be a very good solution, because it will reduce the overhead of CPU and give the CSP with very stable performance for every user. So we have developed the SRV feature, which we are now live demo in our booth, if you can stop by to check out. So the virtual function quantity is up to 32, and we can support 4 namespaces or 8 namespaces. So we also have other features such as CFB or something other. So we also developing the OCP and TCG OPPO, and it will comes out very soon. So that's all for the presentation, and we also have a booth number 955 if you have time to stop by and check out. Okay, thank you.